This video is about review for final sine and cosine law. For number 5, given two sides and an angle, determine whether the given information results in one triangle, two triangles, or no triangle. Solve any triangles that result. Then label your triangle properly. For number 1, we have angle x equals 55 degrees and x equals 62, y equals 53. We normally put the given angle over here. Then we're looking for, first of all, is the angle y. So we put the angle y here. Then connect these two. We got z. Angle x, that's 55 degrees. We got this 62. Y is 53. So first of all, according to the sine law, we got 62 over sine 55 degrees equals 53 over sine y. Cross multiply. I need to figure out the sine y equals 62 go to denominator. Then we got 53 times sine 55 degrees equals 0.700. Then y1 equals inverse sine of 0.700. Make sure when you use a graphing calculator, the mode is highlighted in degree. Equals 44.45 degree. Therefore, y2 equals 180 degree minus y1 equals 135.55 degree. Then you need to check y2. Using y2, add given angle. Given angle, that's 55 degree. Equals 135.55. Add 55. It's greater than 180 degree. Means this y2 is not right. Which means we have only one triangle to solve. We got the y1, that's 44.45 degree. So for the z, you will get 180 degree minus 55 degree minus 44.45 degree equals 80.55 degree. For this triangle, we need to figure out this z. So we still use the sine law. Z over sine 80.55 degree equals 62 over sine 55 degree. Cross multiply. You will get z equals sine 55 degree go to denominator and 62 times sine 80.55 degree. You will get 74.66. So I label here 74.66. Remember, when you check for y2, you add the given angle. This angle is a given angle. For number 2, we got n over sine n equals m over sin m. Therefore, we got 40 over sin n equals 25 over sin 32 degree. Cross multiply, we got the sin n equals number on the same line with variable go to denominator. That means for this 25 go to denominator. Then 40 times sin 32 degree. We got 0.848. So for A1 equals inverse sin of 0.848 equals 57.98 degree. For N2 equals 180 degree minus N1 equals 122.02 degree. That's for N2. Then you need to check N2. We got to do N2 plus given degree that is a given angle that's a 32 degree. So we got 122.02 plus 32, that's less than 180 degree, which means N2 is a good angle. Therefore, we can sketch graph for this is a given angle M. We got N, connect this. Let's label this is a L. N1, L1. For N2, we still sketch like this. We need to create obtuse angle. So we still get this is M, here's N2, then this is a L2. Then we label these two triangles. 32, this one is a 57.98 degree. 32, this will be 122.02 degree. For this part is 25. This is a 40, 25, and a 40. For this L1, we do 180 degree minus 32 minus 57.98 degree equals 90.02 degree. That's for L1. For this L2, we will get 180 degree minus 32 minus 122.02 degree. You will get 25.98 degree. Now we need to figure out this L1 and L2. For L1 over sin 90.02 degree equals 25 over sin 32 degree. So your L1 equals 25 times sin 90.02 degree over sin 32 degree equals 47.18. For L2, we will do the same thing. L2 over sin, this time is this angle, 25.98 degree equals 25 over sin 32 degree. Cross multiply. Your L2 equals 20.67. Now we label for L2 that's 20.67 and L1 equals 47.18. For number 8, according to the information, we can get the distance between A and B, that's 1,473 meters. We're looking for the height of the mountain, that's labeled as H. From the given diagram, we could see there are more than one triangle. So we need to figure out the common side for those two triangles. Let's find this TB. If there are more than one triangle in the diagram, the common side is very, very important. First of all, we need to figure out this angle. We got to use 41.2 minus 29.7 to figure out this angle. You will get 11.5 degrees. As we know, the exterior angle of a triangle equals the sum of non-adjacent interior angles of a triangle. So we got the angle 1 equals angle 2 plus angle 3. Therefore, 41.2 equals 29.7 degrees at this angle. Then we can use sine law to figure out this x. We got the x over sine 29.7 degrees equals 147.3 over sine 11.5 degrees. So cross multiply. The number who has the same line with the variable go to denominator. Therefore, sine 11.5 degrees go to denominator. Then we got 1473 times sine 29.7 degrees equals. We got 3,660.622 meters for this x. Then we go to this triangle, right triangle. From now on, whenever you have right triangle, use a sine law. Sine 90 degrees equals 1. Sine law is much easier than SOHCAHTOA. So we got x over sine 90 degrees equals h over sine 41.2 degrees. For this x equals this one. So we need to plug in. We got h equals sine 90 degrees go to denominator. Then 3660.622 times sine 41.2 degrees. Put into calculator, you will get 2,411.213 meters. That's the height of the mountain. For number 9, we need to figure out the area of this property. This property is made up of two triangles. For this two triangle area, we got to use 1/2 AB sin C. Pattern, we need to get SAS pattern. We have SAS pattern. So for the area of triangle ABD, you can get 1/2 times 250 times 202, then sine 75 degrees. You will get this number will be the area of triangle ABD. How you get the area of triangle BCD? We need a SAS. So we need to figure out this x. For this triangle, we are given SAS. We need to figure out size. Definitely, we got to use the cosine law. Therefore, we get the x squared equals 250 squared plus 202 squared minus 2 times 250 times 202 cosine 75 degree. You will get, after you get for x squared, you have to do square root both sides. X equals 277.783 meters. Therefore, for the area of triangle BCD equals 1/2 277.783 times 105, then sine 30 degree. You will get 7,291.798 meters squared. Therefore, for area of property, we add these two triangles, we got the 24389.627 at 7291.798. So you will get 31,681.425 meters squared. That's the area of property. For number 10, this circle is divided into 7 equal sectors. One sector is OAB and angle AOB equals theta. For this theta equals 2 pi over 7. Or if you use degree, you got to do the 360 degree over 7. We know area of a sector AOB equals 45 pi millimeter square. Since for sector area, that equals 1/2 theta r squared. This theta means central angle in radian. In other words, we have to use this for theta. So we plug in, got the 45 pi equals 1/2. Theta, that's 2 pi over 7 times r squared. We're looking for this r. This is the power pattern. Therefore, we need to isolate this r squared. Get rid of 1/2, we need to multiply by 2. Get rid of this 7, multiply by 7. Get rid of this 2 pi, we need to divide it by 2 pi both sides. So we got r squared equals reduce. Get 45 times 7. Then we do square root both sides. We got the r equals 17.478 millimeters. That's for radians. Then for B, we need to figure out AB. For this AB, we need a triangle OAB. You are given this angle and r, here's r, radians. So we are given SAS pattern, look for S. We got to use the cosine law. Therefore, we got AB squared equals r squared plus r squared minus 2 times r cosine 2 pi over 7. When you put this into calculator, make sure mode in radian, because we have 2 pi over 7, that's a radian angle. We need to plug R into 17.748 to this R. Put into calculator, you will get, after you get the AB squared equals 237.195, you have to do square root of both sides. So you got the AB equals 15.401 millimeters. For number 11, according to this information, we can label this diagram. We got point C is 195 kilometer north of A. That means this one is 195. Point D is 75 kilometer north of C. So 75. Then the bearing of E from A is 44 degrees. So we got 44 degrees. Then the bearing of E from C is 135 degrees. For A, find the bearing of A from E. So we need to draw this vertical line pointing at the north. We are looking for this angle, bearing of A from E means this angle. Let's extend this line. These two lines are parallel lines because both pointing at the north, and this angle will be 44 degrees because for these two angles, they are alternate interior angles. Therefore, for bearing of A from E will be 44 degrees at 180 degrees. That's 224 degrees. For B, find CE. For triangle ACE, we need to figure out this angle first. That's 135 degrees minus 44. Because 135, that is the exterior angle of triangle AEC. So we got 91 degrees. Therefore, we use the sine law, CE over sine 44 degrees equals 195 over sine 91 degrees. Cross multiply, CE equals sine 91 degrees go to denominator because it is on the same line with CE. Then 195 sine 44 degrees equals 135.479 kilometers will be the distance between C and E. Now let's go to C, find the DE. So we connect DE first. For triangle DCE, we are given SAS pattern. So if we have SAS go to remaining sides, we got to use a cosine law. Therefore, we got the DE squared equals 75 squared plus 135.479 squared minus 2 times 75 times 135.479 times cosine 135 degree. After you get the DE squared, you have to do square root of both sides. Therefore, DE equals 195.830 kilometers will be the distance between D and E.